The mechanism. We'll insert a component. We'll ask it to clinch, and the pin will rise. The hollow cone of the pin will capture the leg, move it in the direction it's been programmed, release it, and then move to the next leg, and that will leave the component with 2 clinched legs. The clinch mechanism moving underneath the PCB. You don't normally see that because the PCB's in position. So we're going to get the machine to clinch a component over here, lifting the board out. This is the mechanism, this is the clinch head, so we're going to move and perform a clinch in this region. We've got a board layout in the programming mode here, and you can see there's a selection of resistors on the board. Those resistors have been positioned by doing an import from our ProCompiler software from the board CAD design and bill of material information. What you can see on this board, however, are a series of coloured triangles. The triangles denote that the legs of those components have been chosen to be clinched, and the colour and the direction of the arrow shows that it's the profile of the clinch and the direction of the clinch. It's programmed with a small utility which you access by right-clicking on the pin in question, and there's a dialog box which gives you the option to select whether you want the lead clinching, the direction it goes, which is clockwise from north, the profile, which is angled about 45 degrees to the board surface, or flat, which is almost level with the board surface. And then you just need to enter the lead diameter and how far the lead projects through the far surface of the PCB, and we use this then to create the movement and the finished clinch profile. And we can demonstrate this by inserting a component into the R1 location, and we'll do a test clinch on that particular leg. So we inserted R1, gentle hold it with the finger, and we press the test clinch button. And the machine will do a clinch, and it also gives you a video image of the finished lead. If I wobble the lead fraction, you can see that's the lead in question that we've just clinched, and it's moved in the direction that we'd wanted it to. I'll do the other leg now. Which is also programmed to be similar. So we've clinched it, the camera shows that one going inwards. So we've got 2 inward facing clinches, nominally 45 degrees. And if we show on the board, this is R1, and that's the end result.
This is a quick demonstration of how to import a Contact's CS400 cut and clinch file into Mascot so that it can be used with the Mascot Clinch System. First, open the Mascot ProCompiler software and select the Contacts file to import. Next, click the Compile button to start the import. You'll be asked to select the CS400 model that the file was originally generated on. In this case, it was a CS400E. As you can see, the component position scans, polarity indication, and pin clinches have all been imported into an assembly file ready for use on a Mascot Clinch system.